Assalamualaikum. My name is Nur Afifah binti Muhammad Rusli. I am from class RCS 1433D. My matrix number is 2020826962.
My name is Rifah Shazwani binti Muhammad Rashid and I am from class RCS 1433E. My matrix ID number is 2020 62 69 and 64.
My name is Nur Fatihah binti Abdul Fattah and I am from class RCS 1433D and my matric ID number is 2020-839-882.
Hi, my name is Nurul Fatul Wahidah binti Muhammad Bostani. I'm from class RCS 1433D and my matric number is 2020626426.
Everyone, now we will go to the chapter 2, which is Law of Logic. For this subtopic, it is almost similar with the last chapter, where we had the limit difference. Okay, as we can see, the double notation law. For this law, we can see that before we had double notation P, and when we equivalence it, it will be P. So, for this law, we want to vanish the double note. So, it will be double notation law. Okay, the other law is almost similar like the last chapter. Okay, but we had a new law which is implication and biconditional. Okay, for implication, when we equivalence, it will be double P or Q. Okay, then it will be implication law. For biconditional, when we equivalence, it will be P implication to Q and Q implication to P. So the example 2.1. For this example, the question asks us to simplify the following statement using the law of logic. Okay, the first step that we need to use is we must move the bracket. So R or not P and R or not R, we put in one bracket, then it will be associative law. Okay, then from R not R, it will be tautology, which is T, and it is in inverse law. Okay, then from R or not P and T, it will be identity law. Okay, so it will be R or not P. Okay, then from that, we must change the position of the bracket. Then it will be R, we put outside, and then it will be associative law. Okay, and for the last, we must move the position of the primitive. And then it will be commutative law, and we will get the answer for this example. Next, we move to the next example 2.2. For this example, the question asks us to simplify the following statement using the law of logic and state the reason. Okay. For your information, the symbol like this, it is similar to the symbol of note. Okay, then the first step that we need to use is we must develop the note outside the bracket in the bracket. So it will be De Morgan's law. Okay, then we must vanish the double note, and then it will be double negation law, and then we use the associative law to move the bracket. So P we put outside of the bracket. Okay. Then from not Q or R is similar like not P or P. Then it will be tautology by using inverse law. Okay. And then P or T, it will be T as the last answer by using the dominant law. Okay. Associate with the conditional statement, the implication to Q, there are three other statements, which is converse, inverse, and contrapositive. For converse, it will be Q implication to P, and then for inverse, it will be not P implication to not Q, and then for contrapositive, it will be not Q implication to not P. We will go take a look at example 2.3. For this example, the question said that given the statement, if tomorrow is raining, then the class will be cancelled. Write the converse, inverse, and contrapositive for the given statement. For converse, it will be Q implication to P. Then the answer will be if class is cancelled, then tomorrow is raining. Okay. For inverse is not P implication to not Q. Then it will be if tomorrow is not raining, then the class will not be cancelled. For contrapositive is not Q implication to not P. So it will be if the class is not cancelled, then tomorrow will not be raining. Okay. We move to the next slide.
So,
what is logically equivalence? Okay, from my point understanding is it was consist by compound proposition that have the same true value in all possible case, and it calls logically equivalence. We should know that what is compound proposition on this subtopic. Okay, usually compound proposition was consist by two statements in both questions that combine, and we call it as compound proposition. Okay, proposition was called logically equivalent when we know that P and Q got the same result value, or we can call it as tautology. Okay, other notation that show it was logically equivalent is P by conditional Q, as I will show in the slide. So we can conclude that the proposition is logically equivalent or not by using the recommended way as using truth table. Okay, so now let's do some questions in this subtopic. Okay, look at the first question is we must show that P implies negation Q and negation R by conditional by P is whether logically equivalent or not to P implies Q or R. Okay, as we look at the question before, we can conclude that it has three variables which is P, Q and R. Okay, we do the third column first and we start by R. How to know that whether it is true or false? That we can use the calculation which is to the power of 0 and we get 1, right? So we can do that. We can do like true, false, true, false, true, false, true, false as the slides that I show until the 8 times. So we go to the second row which is Q, same with R, but we have to change the calculation as P to the power of 1 and we got 2, right? Okay, so the answer will be double, which is true, true, false, false, true, true and false, false until the 8 times. Okay, to the third row which is P, the third variable, we also need to use change the calculation which is 2 to the power of 2. So what we got is 4, right? Okay, when we got 4, we can do the answer like 4 times true and 4 times false, like that I showed that true, 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 true and false until the rest. Okay, now let's see the fifth column which is P implies to negation Q. Okay, at the first we should identify is what variable from the question is. First is we used to see the column of P and negation Q. Okay, but the important things in this question is we use implies, so we should know the rule of implies. Okay, let's say it was given as a question like true implies to true or false implies of false, then the last answer we can give is true. Okay, but if we got the question like true implies false, so what is the last answer? The last answer is false because we should see the last letter, the last variables in the question. So we refer back, the question is true implies false, so the last answer is false, right? Okay, but if we got the opposite question like false implies to true, then the last answer will be true because it was the last variables in the question. Okay, now let's see the next column which is negation R by conditional by P. Okay, let's first identify the variable which is negation R and the second is P, right? So we need to know what the rule in by conditional. Okay, let's say we made the question like true by conditional by true or either false by conditional by false, then the last result will be true. But if we got the question like true by conditional by false, the answer will be false, or either false by conditional by true, it also will be false. It not seems like implies. If implies, we know that false implies to true, it can be true, right? But it not seems like implies because it has its own rule. Okay, we go to the next which is Q or R. Okay, first thing first, we need to identify the variable, as the variable is Q and R, and it use OR, okay, OR. So the rule of OR is we need to identify two false to be it false. What I mean is, if we just got one false in the question, then the last result will be true, okay. The example is like we made the question like true or true also will be true, right? If we made the question like true or false, then the answer will be also true, okay. Then it can be false if only the question asks us false or false, so the last answer will be false. Okay, now let's see the next question, which is P implies to the negation Q and negation R by conditional by P. So let's identify which column it used. So first column is P implies to the negation Q, and the second column is negation R by conditional by P. Okay, it uses the symbol of N. So we know that the rule of N is we found even one false in the question, then the result will be false. Okay, the example is true and false, so the last answer will be false. It just can be true if true and true, then the last result will be true. Okay, we go to the next last column, which is P implies to the Q or R. Again, we can identify the first column is P and the second column is Q or R. Okay, just like before, it use implies, so we know the rule of implies is which true implies to true or false implies to false, then will be true. Okay, so what we can conclude from the question is P implies to negation Q and negation R implies to P is not logically equivalent to P implies Q or R, because it got no same values. Okay, the value of the two column is not same, so that it cannot be logically equivalent. Okay, I think this is all from me. Thank you for watching my presentation.
Next, I would like to explain about forward-backward method. Okay, first, everything that you are assuming to be truth is A, which is hypothesis, and everything that you are trying to prove is B, which is conclusion. To reach the conclusion that B is true, we have to go through backward process, and when make specific use of information contained in A, we have to go through forward process. Okay, next I will explain more detail about backward process and forward process. Backward process is when writing the proof to reach the conclusion that B is true. Meanwhile, forward process is when deriving from the statement A, which assumed to be true, some other statement A1 that known to be true as a result of A being true. It should be emphasized that the statement derived from A and link up with the last statement obtained in the backward process. Next, steps in solving forward-backward method. The very first step is recognizing what is the hypothesis and what is the conclusion, and which is statement A and B. Okay, step 2. In proving A implies B, we must somehow assume that statement A is true and use any formula or information related to reach the conclusion that B is true. Now, let us see the example questions. The question number 1 is from October 2009, question 6. Okay, the question is, proof by the forward-backward method. If P is an even integer and Q is an odd integer, then PQ is an even integer. Your answer should have an analysis of the proof and the condensed proof. So now we move to the analysis of the proof. Okay, like I said before, the steps in proving this, we must have the hypothesis and the conclusion, which is statement A and B. the statement A is P is an even integer and Q is an odd integer. And the conclusion, which is B, PQ is an even integer. Okay, next B1. PQ equals to 2M for some integer M. And next A1, P equals to 2N for some integer M, N. And Q equals to 2K plus 1 for some integer K. You know why we have to put 2N, 2M, 2K plus 1? Because by the definition of even number, we have to write P equals to 2N, and by the definition of odd integer, we have to write Q equals to 2K plus 1. And A2, PQ equals to 2N in the bracket of 2K plus 1 equals to 4NK plus 2N and equals to 2 in the bracket 2NK plus N, and will equals to 2M if M equals to 2NK plus N. This show, the answer show that B1 is proven. Okay, condensed proof for the first question just now. From the hypothesis, P is an even integer and Q is an odd integer. By the definition of even integer, P equals to 2N, and the definition of odd integer, Q equals to 2K plus 1. Then, substitute P equals to 2N and Q equals to 2K plus 1 into PQ, which it equals to 2M, where M equal to 2NK plus N. Thus, PQ equals to 2M for some integer M, and PQ is even integer. Example number 2. The question is, prove by the forward-backward method, if N is an odd integer, then N squared plus 3 is divisible by 4. Your answer should have an analysis of the proof and the condensed proof. So now,
Next, I will tell about a subtopic under chapter 3 named mathematical induction method. When we must use mathematical induction is when B has the form for every integer n more than 1. When something happens where something happens is a statement that depends on the integer n. There are 3 steps we must use in this mathematical induction method. The first one is we must verify that P1 is true, and then replace n everywhere in Pn by 1. Second, assume that Pn is true. And lastly, prove that Pn plus 1 is true, which is start by writing Pn plus 1 and then rewrite Pn plus 1 in terms of Pn. In the next video, I will show the example how to using mathematical induction. For example 1, the question asks, show that n the power of 2 more than 2n for all integer that more than 2. The first step we must do is, we must show that P2 is true. Then, we must substitute 2 into n the power of 2 more than 2n. Second, we must assume Pn is true. And the last part is, we must show that Pn plus 1 is true, which is we must substitute n plus 1 into n the power of 2 more than 2n. And then we will get the answer from n the power of 2 more than 4. We will get n the power of 2 plus 1 more than 5 more than 2 is always true. For example 2, the question 1 to prove using mathematical induction, if x is a real number greater than -1, then for every integer n more than 1, then 1 plus x the power of n more than 1 plus nx. The first step we must do is, we must show that P1 is true. We must substitute number 1 into 1 plus x the power of n more than 1 plus nx. Then we will get the answer P1 is true. Second, we must assume Pn is true. Then it will be true. The last part is we must show that Pn plus 1 is true. We must substitute n plus 1 into 1 plus x the power of n more than 1 plus nx. Then we will get the answer n the power of x2 more than 0. X also can be more than -1. But when x equal to 0, n the power of x squared will be 0 more than 0. It will be true. But when x not equal to 0, x the power of 2 squared will be more than 0. Then the answer will be n the power of x squared more than 0 is true. For example 3, the question asks to use mathematical induction to prove that for each natural number n, 1 multiply 1 factorial plus 2 multiply 2 factorial plus 3 multiply 3 factorial until n multiply n factorial equal to n plus 1 in bracket factorial minus 1. First step is we must show that P1 is true. We must substitute 1 into n multiply n factorial equal to n plus 1 in bracket factorial minus 1. Then we will get P1 is true. Second is we must assume that Pn is true. The third last is we must show that P1 n plus 1 is true using left hand side and right hand side method. Left hand side we must substitute n plus 1 into n plus 1 factorial minus 1. Then we will get the answer n plus 2 factorial minus 1. For right hand side, we must substitute n plus 1 into Pn plus Pn plus 1. Then we will get the same answer n plus 2 factorial minus 1. So left hand side equal right hand side. So the answer will be proven because left hand side and right hand side is the same answer. So it's proven.
As a conclusion from this video, we can see that maths logic help us to understand where the disagreement is coming from. So we can know whether it comes from different use of logic or different blocks. When we already know where it came, then we will be able to solve the problems easily.